we'll take a look. This is the topic, I guess, is data wrangling in R, but really we're looking at the packages tidyr and dplyr. And I'm just using slides that this man Garrett Grolmund has created. He's data scientist and master instructor, and he's actually very good at his job. So I'm just taking his slides. I've linked to them on CCLE, and so we'll use them. I didn't, if there are good slides already created, why bother making some new ones? So no, my name is not Garrett, but if you want to get a hold of him, that's his contact information. We're looking at tidyr and dplyr. That's what we are doing. There are cheat sheets. If you click this link, the picture that they have here is actually the older cheat sheet, and the new cheat sheets are actually, they're pretty nice. All the cheat sheets have been nice, but the information for tidyr is included in data import. The data import cheat sheet covers reader and tidyr, and then dplyr, those functions are covered in the, data transformation cheat sheet, okay? And so, so you can take a look at that. And you can also get the old version of the cheat sheet if you really want the old one. But they are good. You should all download and get those as well. It's worth mentioning tibbles, okay? Tibbles are just like data frames. The only difference is that they play nicely with the console window in that, let's say, you have a small window here, and let's say you call empty cars here, all right? Empty cars is a data set, 32 observations, 11 variables, okay? And what R's default behavior is to try to print out the entire data frame, and if it doesn't fit, it's gonna put, so here I've got 32 observations, and then it only was able to fit 2 columns, so it puts those 2 there, and then it fits another 2 columns, and these 2 columns, these 3 columns, and so on. And this is how it prints out, okay? Maybe I'll just widen my screen a little bit, okay? And so again, it just tries to output the entire thing onto the console window. With if I wrap this as a tibble and call as.tibble empty cars, the difference here is that the tibble will recognize that it can only fit 1, 2, 3, 4, 5, 6 of the variables, and it only tries to fit some of the rows here. It says fits 10 rows and 6 variables, and it says, and just FYI, you've got 22 more rows and 5 more variables that we did not show on the screen. So anytime you print out a tibble, it's only going to print what fits on the screen rather than trying to flush the entire output onto the screen, which can be useful. Sometimes, though, you want the entire data frame to print, okay? So this might be an issue. In this week's homework, you're going to gather in some information, and then I'm going to ask you, print out your results. And if you just leave it as the default tibble form, it's only going to print what fits on the output. And if you want the whole thing, then if this is as a tibble, you can just wrap that in as.data.frame, okay? So the result, if it's a tibble, you just do as.data.frame, and then it prints it just like a data frame. So tibble and a data frame pretty much are exactly the same thing. If we say as.tibble and I ask what's the class on this, okay, it's going to say it's a tibble df, tibble, and data.frame, okay? Meaning if we remember the stuff from the object-oriented programming, it's going to first search for methods that are specific to data frame tibbles, then it will search for methods specific to tibbles, and then if it doesn't find anything there, then it will search for methods for data frames. Therefore, all of the methods that work for data frames will work on a tibble as well. Okay? I hope that makes sense. So tibbles, they're pretty much You can treat them just like a data frame. But yeah, if you try to print out a whole bunch of stuff on a data frame, it runs out. Okay, Tibble doesn't try to do that. Okay. We also have the capital V view command in RStudio. This is something unique to RStudio, and then it will just take whatever data set that you asked about, and it will try to display it. So if you do capital V view iris, it tries to show it in here, kind of like a data frame or like an Excel worksheet up there. Okay, that's just what that does. I think we're familiar with that. And then we've talked about the pipe operator when we did RVest. You know, we said pipes allow us to kind of have this sequential thing where we take the output of one and we pipe it into the next, and these two commands then are equivalent in their function. Okay, data wrangling. Garrett says data wrangling might consume 50 to 80% of your time. That obviously depends on how clean your data sources are. If you got clean data sources, then you don't have to worry as much about it. But if you don't, then you probably have to do a lot of work. Okay, and the idea behind all of this data wrangling is that we want to make the data suitable for analysis, and R prefers the data to look a certain way, and then we also want to reveal information. So I would say tidyr, the package tidyr, is useful for this goal, the first goal, and dplyr is useful for the second goal here. Okay. Okay, so it says data sets come in many formats, but R just prefers one. Okay, the data that we're going to be using today comes from this library EDAWR, which I guess is Expert Data Analysis with R. And the commands that you'll use, it's not a package that is just on the CRAN repository, and you would have to actually install it from GitHub. So you might need to run these two lines of code. I've put the kind of the R commands online in CCLE, and you can download that and uncomment these two lines and run them to do it. And then otherwise you would load up that data set. We're going to look at a few of these, the storms data, and there is a description of each of these data sets in here. Okay, so anytime we're looking at data, it's often a good idea to check the help pages on those things. Okay, so anyway, let's take a look here. So we've got the storms data, the cases data, and the pollution data. Okay, if we take a look at the storms data and we ask, what are the variables that appear in this data set? Okay, what are those variables? We've got the variable storm name right here. We've got the variable wind speed, and it's in that column. We got the variable pressure, and we have the variable date. Okay, so we have 4 variables. Each variable has its own column. This is what we actually like to see. Okay, let's take a look at the cases table. What are the different variables that we have in cases? One is the country name. What's the other variable that we have? Huh? It's the year, okay? But look at how the year is stored. The year is stored as column headings, okay? It's not in a column. Their column headings is the year, okay? And then so what does that make all of this stuff down here? All of this stuff down here would be the kind of the count of the number of tuberculosis cases, which is what this data is about, okay? So this is not in the same form here. We've got, rather than one column per variable, we've got the name in a column, then we got the years as column headings, and then the values themselves are spread across those columns, okay? And then if we look at this this data set, okay, yes, we have the column and variables city, particle size, and amount, okay? So that's true. We've got city, particle size, and amount. Those are variables that we have. But if we look at this, we have, kind of 2 rows for New York, 2 rows for London, and 2 rows for Beijing, okay? And so if let's say we only wanted to have 1 row per observation. Well, in that case, the variables names that the variables that we actually have are the city, New York, okay, London and Beijing, okay, and then the other two variables would be the number of large particles and the number of small particles, okay, and so that's like an entirely different form, all right. So and this way we would have, you know, kind of one row per observation and one column per variable, but the data is in different forms here, and we like to have data where we've got one row per observation and one column per variable, and we call that tidy data. So when our data is in tidy form, we can select our variables very easily. We just say storms, $ storm for the storm name, or $ wind for the wind speed, things like that. If we wanted to select the values for each variable in this thing, we'd have to use some kind of tricky formatting here, or over here, you know, you'd have to specify the odd rows versus the even rows. It's just a headache to try to get these specific variable quantities if they're not in tidy form. Okay. Another benefit of having data in tidy form where you have one column per variable and one row per observation is that you can do calculations taking advantage of R's vector arithmetic, right? And so if you want to find the ratio between pressure and wind, you can just do storms $pressure divided by storms $wind, and R will understand to take each value and do vector arithmetic and match, you know, each one. For whatever reason, the values that appear here are wrong, but you know, do 1007 divided by 110, 1009 divided by 45, so on and so forth, and that would create kind of our resulting values that we can use. Okay, so once again, if our data is in tidy form, each variable has its own column and each observation has its own row. So that's what we have. Okay, and all of each type of observation, in this case, each type of observation is a storm, is stored in the one table storms. So that's what it means to have tidy data, and this is what we want to get our data to go in. Okay, so the question is, how do we get data such as the cases or the pollution data to look like the tidy data storms? Okay, how can we do that? That's where the package tidyr comes in. Okay, and in fact, so Hadley Wickham is the author behind tidyr, and he considers this to be so foundational that all of his packages he kind of puts under the umbrella of the tidyverse. Okay, the tidyverse packages. And there are two main verbs, or two main functions that we use in tidyr, and that is gather and that is spread. Okay, gather and spread, those are kind of the two main functions that we use to reshape our tables. Okay, so if you haven't done this, you'll need to do install.packages tidyr on your machine, and you can load up library tidyr. Okay, so let's take a look at this thing. Okay, so if we were to reshape the cases table into tidy data, how many columns would the resulting table have? 3 columns, right? Those columns would be country, year, and end. Okay, so we would have 3 columns, country, year, and end, because those are the 3 variables that we have. How many rows would our resulting table have? It would have 9 rows. It would have 9 rows because each of these values down here would be considered in its own separate observation, and they would have their own row here. Okay, so let's just take a look. And so we would have the country, the year, and the number of cases, and we would have this first value, France in the year 2011 with 7,000 cases would go right there. Then Germany in 2011. And US in 2011, and then France in 2012, Germany, US in 2012, France in 2013, Germany, and US. Okay, so we'd have a total of 9 rows in our resulting table. Okay, 3 columns: country, year, and number of cases. And now we have tidy data. Each variable is in its own column, and each observation has its own row. And the verb or the function that we use here is called gather. The reason why it's called gather is because our data right now is across 3 columns. It's across the columns 2011, 2012, and 2013. And what we are doing is we are gathering the values across 3 columns, and we're gathering them into one column. The column that we're gathering them into is the column N. So we're taking values that are spread across 3 columns, and we're gathering them into one. So this is the function gather. Okay? How does this work? Oh, so the function will require the names of the key. Okay? So we're going to take the column headings, 2011, 2012, and 2013. Those form the key values. Okay? So this is value 2011, 2012, and 2013. They come from the column headings. And then the values that we are gathering together, those are kind of the former cells here, and that's going to be the value argument. So how does this work in tidyr as a function? We're going to call gather. We give it the table or the data frame that we are applying the function to. So cases, we want to transform this table. So we're going to say gather the data in cases. And here, we give it the name year, okay? This is just an arbitrary name. If you want to call it Y, if you want to call it, year where we measured the data, you can call it whatever you want. There's no inherent meaning to this string, to the letters Y-E-A-R. It could just be anything. You want to say año for whatever it is, you can do that. And then over here, again, this is just another name to be the name for the value column, okay? So it doesn't, there's no inherent meaning. Here we're using year and N because those names make sense, but you can name them whatever you want. And then lastly, these are the columns that we are gathering. We are gathering columns 2 through 4, okay? So if we look back at the cases table, we are gathering the data in columns 2, 3, and 4 into the N column. Okay, and so that's why we are doing 2 through 4. And then year and N, those are just the names that get produced. Okay, so when we do that, we have gather cases, year, N, 2 through 4. It's going to take the data in columns 2, 3, and 4 and put that into the column N. The column headings become values in the year column. All right. So let's so here I have the table cases, okay? And so I can just say cases, and here I'll just use the pipe form, okay? And we're going to run it into gather. And I want to gather, and the resulting thing I'm going to call year. And then maybe I'll call it N. And the columns that we're gathering are columns 2 through 4. Okay? And so there we go. Here, if I use capital Y-E-A-R, and again, there's no, you can call it whatever you want. Okay? Number of cases, that's fine. That's what we have there. Okay, does that make sense? So here's our original table, and we're gathering these things in. What would happen if, instead of gathering columns 2 through 4, which makes sense, we're going to gather 2011, 2012, and 2013. What would happen if I say we're going to gather columns 3 and 4? What would we end up having? If I gathered columns 3 and 4, we are taking the data in columns 3 and 4 and we're combining them into one column. So how many rows would we end up having? we would end up having 6 columns. And then so what happens to the information stored in column 2011? It just gets repeated here, okay? So columns 3 and 4, the 6,900 and 6,000 and 14,000 in 2012, those go down here. 7,000, 6,200, and 13,000, those go down here. But then these values, 7,000, 58, 15,000, those get repeated here. In the same way that the names FRDE and US get repeated, they get repeated here as well. Okay. Now we wouldn't want to do this because this doesn't make sense, but we can tidyr will just do what you ask of it. Okay. It's not smart enough to recognize all of these columns should belong together. So it's just gonna do what you ask. So it makes sense to gather columns 2, 3, and 4, and that's what we can do. But here's what we have, all right? What if I, so here I have cases, and maybe I will, Paris, Berlin, Washington, okay? So if I, let me say cbind cases and cap. Does this work? Okay, so if I have this, right, I think this kind of would make sense if I take cases and we're going to gather columns 2, 3, and 4, because this is still what we have. And I think this makes sense, right? So the column that I did not gather gets repeated, okay? And then the columns that we gathered, those get put into the column, the key name, the column headings go into the key, and then the values go into the number column there. Does that make sense? Okay, so we have that. So that's gather. Let's talk about the other form. So what if we have data such as, and we wanted to reshape them to be tidy. So in this case, we've got the variables city, large, and small. How many rows would we have in the resulting data set here? So here I have 6 rows in my original data set. If I change this to just city, number of large particles, number of small particles, how many rows will I have in the resulting data set? 3, right? I would have 1 for New York, 1 for London, and 1 for Beijing, okay? So over here I would have 23 goes under the column large, 14 goes under the column small, 22, so on and so forth, and I would have 3 rows, 3 columns here, okay? And again, 1 column per variable and 1 row per observation. This is called spread because we are taking the values in 1 column, in this case the amount column, and we are spreading them out across 2 columns. So that's what we have there. Okay, how does this work? It kind of works in the opposite or the inverse of the way gather works. Okay, so now we specify the column key and we specify the value, and then spread will figure out kind of, you know, the unique values in the key column and the and match them up appropriately. Okay, so here it says, you know, we've got large and small, large and small. I've got 2 unique values, so I'm going to have a column for large and a column for small. So here we're going to say we're going to take the table pollution. The information that we want to create our keys are in the column size, and then the values that get spread out are in the column amount. Okay, so here the names do matter because they have to be names that actually exist in the original data set. Okay, so this is the column to use for keys. This is the column to use for values. Okay, so let's take a look at this in R. We're going to take our pollution data. okay, which looks like this. And I will, I'm going to say pollution, and we're going to spread using the column size as our keys, and we're going to take amount, and we're going to spread those out across large and small, like that. Okay, does that make sense? What happened there? Okay, this is case sensitive, okay? So what if I'm going to go ahead and we'll take our table pollution, and I'm going to change that first entry of large into capital large, like this, okay? So let's look at what pollution looks like now, okay? So I've got New York with capital L large, okay? Small, large, small, large, small, okay? So if I run the same command here, pollution, spread, size, and amount, what will my resulting table look like? So with the original data, where everything was formatted nicely, I ended up with 3 columns and 3 rows. What will I end up having after I do this? How many columns will I end up having? We will have 4 columns, okay? Because what it's going to do is it's going to look at this column size, and it's going to say, how many unique values do I have? And we've got capital L large, small, and lowercase large, okay? So it recognizes those as the 3 unique values, and they each get their own column. So here, it's going to say, okay, Beijing has 121 lowercase large and 56 lowercase small, but it has no value that corresponds to capital large here, okay? And likewise, New York has no value that corresponds to lowercase large, but it has the value 23 for all caps large here. So, so it does matter that when you spread the data, that you kind of have that they match up correctly, because otherwise, spread is not going to. It will not match this with the capital large with the lowercase large and things like that. It looks for the unique values in this column, and it spreads it out that way. Okay, let me fix that. Just back to large here. Okay, so this is again our original data. Pollution. Okay, I'm gonna mess around. I'm gonna do pollution, and we're gonna change this. I'm gonna change New York to NYC. Okay, so pollution looks like this now. And what if I spread this? I say pollution, spread, size, and amount. So this is what it looks like when we do to the original data, 3 rows, 3 columns. What will I end up having here? How many columns will I have? I'll have 3 columns because I only have 2 unique values for size. How many rows will I have? I will have 4 because I've got 4 unique rows for 4 unique values under the city. Okay, so I've got Beijing, London, New York, and NYC. It recognizes that it's got large and small for each of these things, but for New York spelled out, it only sees it's got value for the small and nothing for large. And for NYC, it sees it only has values for large and nothing for small. Okay, so you want to kind of make sure this works. So when things are formatted correctly, spread will work well. Okay. But basically, it's just taking the values in your key column that you provide, and it will look for the unique values, and each of those unique values get its own column here. Okay? And there is definitely a relationship between the results of spread and gather. If you've got data in this form and you spread it, it will go like this, and then this looks kind of like the cases table, except the cases table had, what, 2011 and 2012 and stuff like that. If you gather those data spread across multiple columns into one, that's going to be the verb gather. So there's an inverse relationship between the functions of spread and gather. Okay. All right. Is that okay? Are there any questions there? Okay. There's another functions, pair of functions, unite and separate, which are inverses of each other, but I'd say they're less important in that here you might have a column like date. Okay, I'm trying to think how often you do something like this. And you might want to parse this out into the date. You want to parse it out into year, month, and day, and you can do something like that. It basically takes a character string and it splits it up. So, you know, if people are turning in file names and it's like homework 2 _ first name _ last name, maybe that's a time you can use it to parse things out. But again, that requires everything to be formatted nicely. But it can be done if you need to do something like that. And if you needed to do the opposite, where you have data in multiple columns and you wanted to paste them together in one, you can use the command unite, okay? But I've never done this in real life, but they exist, okay? Because you know, I suppose the need could arise. All right, so again, with tidyr, we've got gather and we have spread, and those are our two main functions for tidyr. Okay, to reshape our data into the form of having one column per variable, one row per observation. That's what we want with tidy data. Okay, and you've got an exercise. There's just one exercise that requires the use of tidyr in your homework. In homework 3, that's in part 1, the last chunk in part 1. Okay. It says data sets contain more information than they display. That's often true. And so here now we will introduce the package dplyr. Dplyr comes, the main functions that you use in dplyr are select, filter, arrange, mutate, summarize, and group by. And today we'll get through mutate, and then I think on Wednesday we'll probably cover the summarize and group by, which is, in my opinion, really the awesome part of dplyr. But we'll cover the still awesome, but not as super awesome as summarize today. Okay, so if you haven't done so, install dplyr onto your computer, and then we'll take a look at these things. We're not going to really look at the New York City flights data. Okay, so let's we'll look at these 3 variables or functions today: select, filter, and mutate. Select is for selecting variables. Filter is for selecting observations. Okay, so if you want to select columns, that's select. If you want to filter down to rows, filter particular rows, that's when we use filter. Okay, mutate allows us to create new variables based on, I guess, the existing information. And then summarize changes the unit of analysis. All right, and that's pretty much what a summary statistic does, right? When you take a summary statistic such as the mean, what you're doing is you're taking a bunch of numbers, like a sample of numbers, and the mean takes all of that and it boils it down to one number, right? Same with the standard deviation. You got a bunch of numbers and it boils it down to one number, okay? So that's what summarize will do, is it takes a bunch of numbers and it boils it down to, you know, one number, or, you know, if you've grouped them, then a few different numbers. But we'll look at select, filter, and mutate today. Okay, so select, the way it works is you just give it, you say select the name of your data set and then the columns that you want to select, storm and pressure in this case, all right? You know, after I've gotten used to using pipes, I often find myself just naming the data set first, such as storms, and then I'll pipe it into select this way, and I'll say select, and I want to select the names, column storm and pressure, and it selects that accordingly, okay? So I often write things this way, but I don't want you guys to be startled or anything. It's exactly equivalent to writing it this way, okay? So of course, you know, whenever you're trying to figure out which columns to select, it's helpful to know the names of the columns. So you just say names of storms or names of whatever data frame you're looking at. And here I only have the columns storm, wind, pressure, and date. And so in this case, if I do storm, select storm and pressure, it's going to select those columns. Just like subsetting other things, you can put a minus, and that will say select everything but storm. Okay, and notice when I'm using dplyr, I don't even have to put quotes around storm. Okay, dplyr will recognize the command. So oftentimes if we did character subsetting or subsetting based on a name, you would have to put, so it actually doesn't even like this. You would have to put quotes around it, but here you can leave off the quotes and it will operate here. Again, if we look at the names in storms, we can use colon notation, and we can say select the columns wind through date. Okay, and that will select wind, pressure, and date, because the colon notation, dplyr recognizes you want wind through date, those columns as well. Okay, you have so there we have storms, select everything but the column storms, or select the columns wind through date. Those are possible. And we have other, dplyr also provides us additional ways to select columns, okay? So we have things such as contains, ends with, starts with, okay, and this refers to the name. So I can say storms, and we want to select everything that ends with a, in this case, we're going to say ends with a D, and that will select wind, okay? Or we could say contains D, okay? And then it will select wind and date, right? So you can specify things. So if you have a bunch of columns and maybe one of them is like arrival time, departure time, transit time, or something like that, you can say contains time, or ends with time, or starts with whatever, okay? So these are ways, convenient ways to select certain columns in our data frame, right? And you've got other things as well. And of course, you can use old-fashioned things, right? You can say, I want columns 2 through 4, and it will select columns 2 through 4 as well. Okay, so that's selecting columns. The other another verb is filter, okay, or function is filter, and that is that selects rows that we want, all right? And so often we'll just give it some kind of criteria, such as I want the rows where wind is greater than or equal to 50. It's kind of like subset, but it's dplyr, and so I would argue probably superior to subset. So again, if we look at the, here's our original data frame, or Tibble storms, and I can say storms, and let's filter it. So we want wind to be greater than or equal to 50, and it will just select the rows where wind is greater than 50, okay? If you give it multiple values as far as what to select, then, so in this case, I can say select storms, comma, and the storm name has to be in the set Alberto, Alex, or Allison, or in this set. Then it basically applies an and. Okay, so it's like filter so that wind is greater than 50, and filter so that storm is in this set of accepted names. Right? So you can have it that way. You can also, if you wanted an or statement, so generally if you put in a comma, then that will apply an and. But if you wanted or, you can use just the or operator, okay? The vectorized or operator, and then we have the vector. So now we have the names Alberto, Alex, and Allison, and then we also include Arlene because wind was greater than or equal to 50 there. So this is filter. All right, is that good? And again, you can always, whoops. And just like before, you can pipe things. So you filtered the rows, and then let's say now you just want to select the columns storm and pressure. Okay, and so you can do that. You just pipe the results of the previous thing. So we have storms, pipe it into filter. We've filtered it, and then now we're going to pipe it into select, and we just select the columns that we want. So you can just continue to pipe the results of the previous thing into the next. Okay, so that's filter. And I think we're used to seeing these kind of comparison or logical operators. All right. And then the last function that we'll take a look at today is mutate. Mutate allows us to take kind of some of the variables that we have here and basically give us a new variable. So in this case, let's say we want to calculate the ratio between pressure and wind. All we have to do is we say mutate the data frame, and then we're going to define the new variable. The new variable is called ratio. How do we calculate the values for ratio? We're going to take pressure divided by wind. Okay, and so it does that, and it gives us the column ratio here. Mutate is smart enough to know that if you defined a new variable here, such as ratio, you could use that for another variable that you want. So here I've got inverse equal to ratio raised to the -1. Okay. Normally in R, there is a way to create new variables in R, except if you wanted to do something like this, where you create a column ratio, and then you create a column inverse, which is based on the result of ratio, then you would have to create this table first, save it, and then you can create this column and save that. Okay? But with mutate, it's smart enough to know, oh, you've created this and now you want this. It's not going to complain that this thing doesn't exist. It will see it as something that it has created and create that as well. So that's a really nice thing about mutate. Okay? When we use mutate, we have to keep in mind that the result of mutate should have one entry for every single row. So we would not use functions like sum or mean in a column that we create using mutate. Okay? Because mean takes a bunch of values and it turns it into one value. Same with sum. It takes a bunch of values and it turns it into one value. So those functions are not appropriate to be used in mutate, because mutate needs to produce one value for every single row. Right? So we have something called window functions. Okay? These are known as window functions. So instead of sum, we would have something like the cumulative sum. Okay? And so the cumulative sum, so here, like if I take the values 1 through 10, and I say I want the sum of 1 through 10, it's going to take all 10 numbers and turn it into a single number. But instead, if I say cumulative sum of 1 through 10, then it returns back 10 numbers, and what it is here I've got, it start off with 1, then it says what would happen if I add 2, then I would get 3, and then if I add the next number I would get 6, and so on, and it would increase the values this way. All right, and you also have cumulative mean, and that increments that way as well. Okay, and so cumulative sum and cumulative mean are appropriate because those are window functions in that you give it a vector of values and it will return a vector of results rather than a summary value. Okay, so summarize is mostly for value functions that take a bunch and return one number. Here we have window functions. Okay, and so we have p min and p max. These are element-wise min and max. Okay, we've got cumulative min and cumulative max, and then cumulative sum and product. Okay, so cumulative min and max would be something like I'll call x as sample 1 through 10. Okay, so here's x, and if I say cumulative min on x, it's going to say it's going to keep going. It's going to say, all right, so far the smallest value I've seen was 6, then 5, and then 2 is the smallest value I've seen, and then finally when I see the 1, then that's the smallest value I've seen so far. Something like that, right? So that's cumulative min and things like that, okay? And you have other values such as the cumulative mean, the lead, or the entile, and things like that, okay? So these are just different window functions that will take a vector of values and return a vector of values, which are appropriate for doing mutate, okay? Or just simple vector operations, right? Take the column pressure, take the column wind, and divide, and perform element-wise vector division or multiplication or things like that, okay? And so that's what we would use the function mutate for, okay? On Wednesday, we will continue on, and we'll take a look at summarize and group by, and this, I think, really adds power to dplyr. And so, so we'll see you guys on Wednesday to continue on with that there. All right, well, have a good day, and we'll see you guys in a couple, not too long.